In this video, we're going to use a second derivative test to find local extrema of an algebraic function. And it says, use the second derivative test to find the location of all extrema in the interval -6 to 2 for the given function. So they give us x minus 8 squared over x minus 2. We need to find the two derivatives to start this. So I'm going to go ahead and say that we're going to look for f prime of x. And to find f prime of x, we're going to say that u is equal to x minus 8 squared. So u prime is going to be 2 x minus 8 chain rule. So I take it times derivative of x minus 8. And so I end up with u prime, which is still equal to, I should have just said, that's equal to, that's derivative would be 1. So I end up with 2 x minus 8. So then v is equal to x minus 2. And v prime would be equal to 1. So let's use this quotient rule here. U prime times v. So I get 2 x minus 8 times x minus 2 minus, we take the 1 times x minus 8 squared. So we get x minus 8 squared over v squared. So that's x minus 2 squared. Okay. So then if I want to take the second derivative, well, let's first find the critical points here. So you can see that this, let's look at we know that x minus 2 squared, we're going to write this up here. So x minus 2 squared going off of this denominator cannot equal 0. If I square each side, I get x minus 2 cannot equal 0. So if I add the 2 over, I get x cannot equal 2. So if we're looking from -6 to 2, and 2 is not part of our interval, so when I get this x value cannot equal 2, I don't really need to worry about it at all, because even though it's a domain restriction, we're using a specific interval that does not include it. So I'm going to say no domain restriction here. If I want to find the critical points for a rational function, I'm going to set the numerator equal to 0. So I'm going to say 0 equals 2 x minus 8 x minus 2 minus, and I'm going to write this out as x minus 8 x minus 8, like so. And then what I'm going to do is I'm going to factor here. I'm going to factor out x minus 8. So I have 0 equals 2. Well, no, I'm going to say x minus 8. And then in here I'll have 2 x minus 2 minus x minus 8. And then I'm going to use zero product property here. So I'm going to say x minus 8 equals 0, or, and then I get, I'm going to say 2 x minus 2 minus x minus 8 equals 0. So I end up with x is equal to 8, or if I distribute here, I get 2x minus 4 minus x plus 8 equals 0. This will end up being x plus 4 equals 0. Subtract that 4, we get x is equal to -4. Now we have two critical points here. We got, we're going to call these critical points. But 1 is not in the domain, right? 8 is not in this domain. -4 is. So we're going to ignore the 8 part because it's not in the domain. So we're just going to focus on x equal -4 for the rest of this problem. And then what we're going to do is we're going to find the second derivative. So I think the way to find the second derivative, the easiest way, would be maybe to rewrite this all multiplied out. I'm trying to think. That would be best. That'd probably be best. So let's distribute some stuff here. We're going to write that f prime of x is equal to, if I multiply this, we would have 2, and then it would be x squared minus 8x minus 2x plus 16. Just multiplying these two together. This piece would be then minus x squared minus 16x plus 64. And then over, on the bottom we have x minus 2 squared. We're going to get, that'd be x squared minus 4x plus 4. Let's simplify that a little bit. So we get f prime of x is equal to 2x squared minus 16. Well, this is minus 10 times 20, or times 2. So that's minus 20x plus 32 minus x squared plus 16x minus 64. All over x squared minus 4x plus 4. So then I get f prime of x is equal to, if I cancel this 2x squared and the negative x squared, that'd be just x squared minus 4x, negative 20 and 16. And then 32 minus 64 would be negative 32, all over x squared minus 4x plus 4. Now I'm going to have to do the quotient rule again. So we're going to say u is equal to x squared minus 4x minus 32. So I've got u prime being 2x minus 4. V is equal to x squared minus 4x plus 4. So v prime is equal to 2x minus 4. I'm going to take u prime times v. So f double prime of x is equal to, this would be 2x minus 4 times x squared minus 4x plus 4 minus 2x minus 4 times this piece times x squared minus 4x minus 32. And then I'm going to divide all this by v squared, which would be x squared minus 4x plus 4 squared. This is going to simplify to, if I'm going to distribute, that's 2x times x squared. So I get 2x cubed minus 8x plus minus 8x squared plus 2x times 4 would be 8x minus 4x squared plus 16x, and then minus 16. We're going to take this and write minus, this will be 2x cubed minus 8x squared minus 64x minus 4x squared plus 16x. And then 4 times 32 be positive 128. I'm going to write this all over x squared minus 4x plus 4 squared. So you're going to see some cancellations here. So if we distribute this negative to each term, we're going to have some big time cancellations here. Let's go ahead and do that. So we're going to get 2x cubed minus 8x squared plus 8x minus 4x squared plus 16x minus 16 minus 2x cubed plus 8x squared plus 64x plus 4x squared minus 16x minus 128 all over x squared minus 4x plus 4 squared. Okay, I'm going to rewrite all this right up in this area. So the 2x cubes cancel. Negative 8x squared and 8x squared cancel. We've got, oh boy. We have positive 16x and negative 16x cancel. Where did I get the 64x from? 2x times negative 32. Okay. These cancel. And then I'm left with let's see. What am I missing? I feel like I'm missing something. I got 8x, 64x. So that's 72x. (72x) minus 144 all over 72x minus 144 all over, let's see. This will be x squared minus 4x plus 4 squared. Okay, we're going to go ahead and do the second derivative test now. So we're just going to have a chart. We're going to write negative 4. That's our critical point, so I'm going to write CP. And then we've got the sign, and then the conclusion. So the sign of, I'm going to say f double prime of x. And this is f double prime of x. So I'm going to plug negative 4 into that. So we're going to say f double prime of negative 4, and I'm kind of out of room to write, so I'm going to put all this in the calculator. 72x minus 144. And then on the bottom, we've got x squared minus 4x plus 4 squared. And I'm going to save negative 4 as x. I get a negative number. So my sign is negative here. So my conclusion would be that this is, if my sign is negative, I'm concave, I'd be concave down. So I'm concave down, which means that I've got a maximum here. So I've got concave down, that's a maximum for my critical point. So my conclusion would be maximum for x equal negative 4.